This is section 5.4, conditional probability and the general multiplication rule. Our objectives are to compute probabilities using a contingency table and the general multiplication rule, to compute conditional probabilities, and to solve general real-world probability problems. We'll start with contingency tables, and in this example, we're to compute probabilities using the contingency table. In a recent poll, high school students were asked to choose their favorite game and their favorite snack to eat while playing games. The results are presented in the following contingency table. Give both a simplified fraction and a decimal rounded to 3 decimal places. So we see our contingency table here where the columns are the responses to the snacks that they chose to eat. They were given these options: pizza rolls, chips and dip, and cookies. And the rows are the games that they were given to choose from: poker, Trivial Pursuit, Monopoly, and Wii Bowling. So for example, you can see that 10 students said that their favorite game is poker, and they like to eat pizza rolls when they're playing poker. So we also see that the totals for the columns down at the bottom: pizza rolls total 44, chip and dip 41, cookies 30, and then the rows, the total number of students who chose poker or Trivial Pursuit, Monopoly, or Wii. So the totals for the rows and the columns should be the same when you sum them up, and they sum to 115. So that 115 tells us how many students were in this survey. So our first question is, what is the probability that a randomly chosen student prefers cookies? So I'll use this notation: probability cookies, probability of that event, that cookies were chosen. So we know out of 115 students, that's our denominator, the total number of trials. So 115 students were asked. On the top, how many ways did we get the cookie answer? So we look at the cookie column and we see 30 students chose cookies. So it's 30 out of 115. And now it says give both the simplified fraction and a decimal rounded to 3 decimal places. So first we do have to simplify. Now remember how to do that. You can use your TI-83 or 84 calculator. You type 30 divided by 115, get that result, then hit the math key, and then enter, and that should give you your simplified fraction of 6 over 23. Now to find the decimal, which you saw just a minute ago when you did this division, now we'll just do 6 divided by 23, and that's 0.2608. 3 decimal places, that's why I took it out to 4. So now I can decide if I'm going to round up or just cut the last digit off, and I am going to round up, so this is approximately 0.261. So 0.261 is the probability that if we chose a student out of these 115 students, they would have been one that said they preferred cookies. Or another way to look at it, if we change that to a percent, 26% of the students said they would prefer cookies. What is the probability that a randomly chosen student's favorite game is poker? Probability poker. Again, this is out of all 115 students. Poker had 25 students who selected that. Again, 25 divided by 115, and then we do our math, enter, and you get 5 out of 23. There's our simplified fraction, and we get 0.2173, which then would be, of course, the 3 would not tell us to round up, so it's just 0.217. Okay, what is the probability that a randomly chosen student prefers cookies or that their favorite game is poker? Okay, probability, we saw what the or means, right? Cookies or their favorite game is poker. So remember, that means they either chose cookies, or they chose poker, or they chose both, right? That's what A occurs, B occurs, or both. All right, so we saw a formula for that, but I told you don't have to memorize the formula as long as you don't double count. So what are the cells that include that? Each one of these little boxes is considered a cell. So what we can see is for cookies, or let's see, yeah, for cookies, there's these 12, these 7, and these 4, or all this total of 30, right? But notice if we do poker, we got these right here, and if we do poker, then notice what would happen. We would count those 12 students twice. If I take 30 plus 25, this is that and poker and cookies, I would have counted those 12 students twice. So here's what I'm going to do. I'm going to do cookies, there's 30, plus, so I've got all these cookies students, but what I didn't get yet were these 10 and these 3 students who chose poker but didn't choose cookies. So in a contingency table, you can see where the double count is. If you have a row and a column, you're going to have an overlap, and that's where you don't want to double count. Or use the formula and it will keep you from doing that. Okay, this is still out of 115 students, so we have 43 over 115. And that, when you take this 43 divided by 115, math enter, it will tell you that that is the simplified fraction. It returns the same fraction to you. So our division gives us 0.374. Okay. Part D, what is the probability that a randomly chosen student, so again, we're just choosing one each time. We call that a single trial. You're just choosing one student, but they prefer cookies and their favorite game is poker. So you get one student to pick. What's the probability their answer was cookies and poker? So let's write that. Probability cookies and poker, but I want to make something clear. Single trial. Okay, I'm just choosing one student, cookies and poker. Out of 115 students, how many chose both cookies and poker? It's going to be the intersection of cookies and poker, those 12 students, right? That again will not simplify, but try it, see if it will, so you'll know how that works. Okay, this last one, part E, is a little bit different. What is the probability that when 2 randomly chosen students are selected, the first student prefers cookies and the second student's favorite game is poker? So this is a probability of cookies and poker, but not in one trial. First is cookies, second is poker. This is not a first second. This is one student who gave both answers. This is the first student prefers cookies, the second one prefers poker. And this is going to be the multiplication rule, right? Because it's a multi-stage procedure. You're going to do one thing, then another. Like we've seen in the past, you spin the spinner and then you roll a die or something like that. So it's multi-stage. So we want the probability of cookies, and that one is, well, we had it simplified up here, probability of cookies. We can use that 6 over 23, or you could write 30 over 115. We already have that. And poker, again, we had 25, or you could use that number or you can use this one because you'll get the same answer. And we get 30 over 529. As a decimal, that's 0.057 with some rounding.